All right, today we're cracking one of the internet's biggest yet most invisible mysteries. We're basically going on a detective story to uncover this system that works tirelessly behind the scenes every single time you go online. We're talking, of course, about the Domain Name System, or DNS.
I mean, think about it for a second. You type a simple name into your browser, say example.com. You hit enter, and poof, like magic, the website just appears. It happens in the blink of an eye. But what is actually going on in that split second? How on earth does your computer know where to find that specific site on the massive, sprawling internet?
Well, that magic is really just a lightning-fast translation service. It's an absolutely crucial piece of internet infrastructure called the Domain Name System, or DNS for short. It's basically the engine that converts the website names we understand into the addresses that computers need to actually talk to each other.
So, to solve this whole mystery, we're going to follow 4 key lines of investigation. We'll start with what DNS is using a simple analogy. Then we'll trace the journey of a single request. We'll meet the key players, the servers, and finally, we'll look at the details and what happens when things go wrong.
Okay, so let's start with the absolute basics. And don't worry, to understand DNS, we don't need to get bogged down in a bunch of technical jargon. All we really need is a simple analogy that I think everyone can instantly get.
So here's the deal. DNS is basically the phone book of the internet. If you remember one thing, remember that. It's the perfect analogy. Just like you'd look up a friend's name in your contacts to find their phone number, DNS looks up a website's name to find its unique online address. And this is the core problem that DNS solves. See, we humans are great with names, right? Example.com is easy to remember. But computers, they don't care about names. They communicate using numbers, these things called IP addresses. So DNS is the essential translator that bridges that communication gap.
Okay, so now that we know what DNS does, let's follow the clues. We're going to trace the exact step-by-step journey your request takes, from the moment you hit enter all the way until that correct address is found.
Now, I know this might look a little complicated at first glance, but don't worry. The best way to think of it is like a chain of command. Your request starts over on the left with you, and it just works its way down the line, asking each server for another clue until, bam, it finds the final IP address over on the right.
So yeah, in a typical lookup, there are 8 main steps. It all kicks off with your request, and it ends with your browser getting the address it needs to load the page. Let's follow the breadcrumbs and see exactly how this whole thing works, piece by piece.
Okay, so it all starts with you. You type example.com into your browser. Your computer has no idea where that is, so it sends the question to something called a DNS recursive resolver. Now, this is usually handled by your internet service provider, but you could also use a public one like Google's. Just think of this resolver as the detective who's been assigned to your case. Its one and only job is to find the address you're looking for.
And this is where the real detective work kicks in. The resolver asks one of the internet's root servers for a lead. The root server is like the main headquarters. It doesn't have the exact address, but it knows who manages all the .com websites. So it points our detective in the right direction, telling it to go talk to the top-level domain server for .com.
We're getting really close now. That TLD server, it knows exactly which server holds the records for example.com. This is the authoritative name server, our final destination. Our resolver asks it for the IP address, and because this server is the official source of truth for that domain, it provides the definitive answer.
And boom, just like that, the case is solved. The resolver sends that correct IP address all the way back to your web browser. Now, with that magic number in hand, your browser can finally make a direct connection to the website server and ask for the web page. And the craziest part, all of this happens in milliseconds.
Okay, so we've seen the journey, but who are these key investigators that make it all happen? Let's get a proper introduction to the 4 types of servers that work together to solve every single DNS query you make.
All right, here are our 4 main players: the DNS recursor, the root name server, the TLD name server, and the authoritative name server. Each one has a very specific and very crucial job to do in this whole process.
First up, we have the DNS recursor, which is also called the resolver. The best way to think about this guy is like a helpful librarian. You walk up and give it the name of the book you want, example.com, and it's the one that does all the running around the library to find its exact location for you.
Next, our librarian visits the root name server. This is like the library's main index, you know, the giant card catalog at the front. It doesn't have the book itself, but it knows which general section to look in. It basically tells our librarian, hey, for anything that ends in .com, you need to go to that section of the library.
And that brings our librarian to the TLD name server. This is that specific section of the library. It's the .com aisle, or the .org aisle, or the .gov aisle. It's in charge of all the books or domains in that specific category. And it points our librarian to the exact shelf where the book is kept. And finally, we arrive at the authoritative name server. This is the actual dictionary on that shelf. It is the official, final source of truth. It holds the entry that says example.com maps to this specific IP address. It gives our librarian the answer, and the quest is officially complete.
All right, now that we've met our investigators, let's look at the actual entries in that phone book and talk about what happens when things go wrong. Because for anyone who works in IT or manages a website, this is where DNS can get a little tricky.
So that phone book doesn't just have one type of entry. It has different kinds of records. The most common one is the A record, which is what we've been following. It just maps a name to an IP address. But you've also got others, like CNAME records, which are basically just nicknames for another domain, and MX records, which are super important for making sure email gets delivered to the right mail server.
So you might be wondering, why don't we go through all 8 of those steps every single time? Well, the answer is caching. To speed things up, your browser, your computer, and the resolvers all keep a copy of recent lookups. But this is a double-edged sword. If a website moves to a new server with a new IP address, it can take time for all those caches around the world to get updated. That delay is called propagation, and that's exactly why you sometimes can't access a website right after someone's made a big change. It's a really critical concept to understand if you ever have to manage a website migration.
So, to wrap it all up, the main takeaway is this. DNS is the invisible but absolutely essential translation service that turns the names we can remember into the numbers that computers need. Seriously, without it, browsing the web would be like trying to navigate a giant city with absolutely no street names or addresses. It just wouldn't work.
But that leads us to one final pretty important question. We rely on this phone book being accurate. What if it's not? What happens when a bad actor manages to scribble a fake entry in there, pointing you to a malicious site instead of the real one? Well, that, my friends, is a whole other detective story for another day.